In this video, I'll be showing you the integrals to memorize. So, let's do this quickly. The first integral to memorize is the integral of a constant. If you have a constant k, the integral is just k times x. Plus c, of course. Don't forget the plus c for indefinite integrals. The next integral to memorize is the reverse power rule. So if you have some integral, some integrand, x to the power of n, the integral of this using reverse power rule is 1 over n plus 1 times x to the power of n plus 1. Another integral to memorize is that if you have some coefficient k multiplied by some function, doesn't matter what function, then you can just factor out the k. This is one of the integration rules. You can factor out any coefficient that you see fit. Okay, how about the integral of 1 over x? Well, you might be thinking the integral of 1 over x, you can use your reverse power rule, but this you cannot. The integral of 1 over x is the natural log of x. Of course, the absolute value of x in the natural log plus c. So for the case of 1 over x or x to the power of negative 1, you cannot use reverse power rule for this. The thing about this guy right here, this integral, is that you need to keep in your mind, in the back of your head, the chain rule versions of this. So all of these are the very simple versions of it. You need to keep in mind chain rule as well, which is u sub. Oh my god, I forgot to put plus c there. Almost forgot. But the integral of e to the x is itself e to the x plus c, of course. Since the integral is antiderivative, and the derivative of e to the x is the same thing, then the antiderivative is the same thing as well. Okay, how about the integrals of the trig functions? Well, the integral of sine of x dx, you honestly don't need to memorize them. You can evaluate them using logic, but if you want to memorize them, that's fine. Sine of x, the integral of sine of x is equal to negative cosine of x plus c. The integral of cosine of x is equal to sine of x plus c. And the integral of tangent of x dx is equal to negative natural logarithm of the cosine of x. And the reason why this is the case is because if you take the derivative of natural logarithm of cosine of x, negative natural log of cosine of x, you get tangent. And the reason why, let's go ahead and evaluate this real quick. Natural logarithm, anything inside the natural logarithm goes into the denominator of a fraction. So you get 1 over cosine of x. Use chain rule with cosine, right? Cosine is a function inside of a function. So if you take the derivative of the inner function cosine, you get sine of x. But remember, there's a negative in front, so if we add the negative, then what we get as a result is the negatives cancel out, and you get sine over cosine, which is equal to tangent. So now we're on to inverse trig function integrals. They get a little more tricky, but if you have some function where a is a constant and you square it plus x squared dx, and you want to take the integral of this is just equal to 1 over a arctan of x over a plus c. And x is just when you just have the variable x, you need to, again, take into account the chain rule variations of this using u substitution. But when you have 1 over the square root of a squared minus x squared dx is equal to, this is equal to arc sine x over a plus c. So keep in mind, there is no 1 over a at the beginning of the arc sine compared to for arctan. Arctan has the 1 over a, arc sine does not have the 1 over a at the beginning. And again, a is some constant. Now, yes, these are really things you must memorize. The inverse cosine functions are the ones that are probably the only one that you kind of can't transfer on from the memorization of derivatives. But with these trig functions, you could transfer that into integrals, like secant squared of x. How about you guess the integral of this? The integral of this is tangent of x plus c. Since the derivative of tangent of x is secant squared, the integral of secant squared is tangent of x. Alright, if you want to take the integral of secant x tangent of x, you just get secant. And again, the derivative of secant is secant x tangent x, which is our integrand, and therefore the integral of secant x tangent x is equal to secant. All right, how about for cosecant x? cotangent x dx. This is equal to negative cosecant x plus c, of course. And that's again because of their antiderivative-derivative relationships. And lastly, the integral of cosecant squared of x dx is equal to negative cotangent. Now, the thing about all these is that they transfer on from your derivatives. If you memorize the derivative identities, then you can memorize these. It's just the backwards version of it. Now, some of the other ones that you might learn are the integral of ln of x and the integral of secant of x. Now, the thing about these is that ln of x requires integration by parts. If you're taking Calculus 1, you don't have to worry about that. I think some Calculus 1 classes learn integration by parts, but most don't. So you don't have to worry about the integral of ln of x until you learn integration by parts. And for secant of x, you don't have to worry about this integral until you are learning trigonometric integrals in Calculus 2 as well. So, as always, if you have any questions, put it in the comment section. And if you found this video helpful, consider subscribing and liking the video. Thanks for watching.